Hi, in this video I provide a short summary of Chapter 1, Section 1, Functions, and solve problems inspired by Thomas Calculus, 14th edition. This series will cover all chapters and all sections with complete problem explanations. Perfect for college students studying Calculus 1 and preparing for midterm exams. In the description of this video, you can find links to download both the blank PDF to try the problems yourself and fully solved PDF to check your solutions. First, this is the second video, and in this video, we will study graph of functions. If f is a function with domain D, its graph consists of points in the Cartesian plane whose coordinates are the input and output pairs for the function f. We usually show the input values as x and the output values as y. Think this as a function machine. Input values comes into the function machine, and we use x for showing the input values, and the function machine, this is the machine name f, for example, takes output values here, and this we can show this as f of x equals y, and this is the input value and this is our output value. For the graphs, for example, the graph of the function f of x equals x plus 1 is the set of points with coordinates x and y, and where y is equal to x plus 1. If y is equal to x plus 1, for the values of x, such as -2, -1, 0, 1, and 2, y takes the values -1, 0, 1, 2, and 3. And the graph of this function is as it is shown here for the y plus 1 and -1. Every point such as -2, -1, -2, -1 should be on the graph of this function. For example, -2, if -2 is here, -2, -1, this point is in here. Then our first question, find the domain and the graph of the function f of x equals 1 minus x. For this function, if we say domain, there is no real value of x that makes the function f of x equals 1 minus x undefined. So the domain of this function is all real numbers, and we show that as like that. And to graph the function, I will make a chart for this. X values will be here, and my y values, y equals 1 minus x, y values will be here. For the x, if x equals -1, then y equals 1 minus 1 equals 2. If x equals 0, then y equals 1 minus 0 equals to 1. If x equals 1, then y equals 1 minus 1 equals 0. To graph the function, if you know the graph of a linear function, you can use these points, or this function is 1 minus x, the slope of this function is -1, and you can already draw the graph without using that, but it's up to you. 1 minus x. Slope is -1. 1 minus x, slope is -1. And for x equals 0, the function passes through plus 1, this is also plus 1. This is the graph of y equals 1 minus x. And now the second or third problem. First problem, 1 and 2. Second problem. Find the domain and graph the function f of x equals x squared plus 1. First, we should find the domain. There is no real value of x that makes this function undefined. So, the domain of this function is again all real numbers. And let's make a chart for the function. X values here and y values. Y equals x squared plus 1 here. For x equals minus 2, y becomes minus 2 squared plus 1 equals to 5. And for x equals to minus 1, y equals minus 1 squared plus 1 equals 2. And for x equals 0, 0 squared plus 1 equals 1. For x equals 1, 1 squared plus 1 equals 2. And for x equals 2, 2 squared plus 1 equals 5. So, those are all the, not all the values, some of the values of the function. And let's draw the graph. This is y-axis, this is x-axis. You should know the graph of y equals x squared. This is the graph of y equals x squared. And if you take this point to here, plus 1, this is now the y equals x squared plus 1. And all these points, minus 2, 5, minus 1, 2, should be on the graph. Minus 2, for minus 2, for minus 2, y is equals to 5, and also for plus 2, y is equal to 5. And for minus 1, y is equal to 2. This means for minus 1, y is equal to 2. Also for plus 1, y is equal to 2. Okay. The other problem. Find the domain and graph the function of f of x equals absolute value of x. Domain. There is again no real value of x that makes the function f of x equals absolute value of x undefined. Therefore, the domain of this function is all real numbers. Domain is all real numbers. And again, we are making a chart for solving function. X and y equals the absolute value of x. Minus 2, minus 1, okay, minus 1, 0, 1, 2. If I want, I will not use minus 2 and plus 2. I will use just minus 1, 0, and 2. For x equals minus 1, y equals absolute value of minus 1 equals 1. Absolute value of 0 equals 0. Absolute value of 1 equals 1. So all these points, which points? Minus 1, 1, 0, 0, and 1, 1. All of these points will be on the graph. The graph of absolute value of x. Let's draw it. X is here, y is here. You should already know the graph of y equals x. this is the graph of y equals x, and the graph of absolute value of x is that one. This part comes to up. Okay, then you should know that this is 45 degrees and this is all again 45 degrees. Now this graph is y equals absolute value of x. Now find the domain and graph the function f of x equals x over absolute value of x. Now domain is not all real numbers. For the function f of x equals x over absolute value of x, the only value that makes this function undefined is x equals 0. The reason that absolute value of 0 is equal to 0 and division by 0 is undefined. So the domain of this function is not the all real numbers. We can say that all real numbers except 0. So this is our domain for this function. And to graph the function, you see if x is greater than 0, f of x equals x over absolute value of x equals x over x, and this is 1. If x is less than 0, then f of x equals x over absolute value of x. Since x here is negative, absolute value of x should be minus x equals x over minus x, and this is equal to minus 1. So if we graph the function here, you will see that this is x and this is y. If x is greater than 1, if 1x is greater than 1, all the values of the function is 1. This is plus 1. When x is negative, then all the values of the function will be minus 1. You see, at the point x equals 0, the function does not have any value. And the next question, find the domain of y equals x minus 1 over 3 square root minus square root of x squared minus 7. To find the domain of this function, we need to check two things. One, the expression inside the square root here should be negative, and should be negative. The expression inside the square root must be non-negative. Sorry for my English, because I'm not a perfect speaking person. Maybe later I will speak more fluently, but nowadays. The second part, the denominator cannot be 0. Here should this part, denominator should not be 0. So first, square root cannot be negative. So x squared minus 1 should 7 should be greater or than or equal to 0. This means x squared is greater than or equal to 7. Then if we make a chart here, this is minus square root of y, this is plus square root of y, 0, 0. Here x squared is 0, here also x squared is 0, and x squared, okay, our function is here, that's one, and plus minus plus. X squared minus 7 is positive here. x square minus 7 is also positive here, and between square root minus square root of 7 and plus square root of 7, x square minus 7 is negative. So we need it to be positive. So x should be element of minus infinity minus square root of 7 and plus square root of 7 and plus infinity. However, there is one point. The denominator cannot be 0. So 3 minus square root of x square minus 1 cannot be 0. So this means 3 cannot be, take this part to the right side, x square minus 7 and square two parts, 9 cannot be x square minus 7. This means 9 plus 7 comes to here, is not x square and not x square. This means x cannot be plus and minus 4. So take this here. So our domain cannot have plus and minus 4. So then we subtract minus 4 and plus 4. This is our domain. And okay, this was the second video. We will see you later.